Anas, welcome. In Form 3 previously, Lesson 7, we were dealing with the molecular formula, examples of molecular formula. We have done question 1, 2, 3, then question 4 and 5 were extended question. So in this lesson 8, we're starting question 6. When a certain hydrocarbon is bound completely in excess oxygen, 5.2 grams of carbon dioxide and 2.16 grams of water were formed. If it is molecular mass of the hydrocarbon, if the molecular mass of the hydrocarbon is 84, determine the molecular formula of the hydrocarbon. Okay, here we have been given the relative atomic mass of carbon and the one for hydrogen. So what we are supposed to do is that we are supposed to first of all have the empirical formula table, or the way that we were doing empirical formula. We are supposed to have the element in hydrocarbon are carbon and hydrogen. Then the symbol for carbon is C, the one for hydrogen is 1. Then the mass for carbon and the mass for hydrogen can be calculated like this. Mass of carbon is gotten from carbon dioxide. So how do you write carbon dioxide? CO2. So how many carbon do you have in carbon dioxide? That's 1 carbon. So what is the relative atomic mass of carbon? That's 12 divided by the RFM of carbon dioxide. So carbon is 12. So 12 plus 16 for oxygen times 2. This one will give you now 44. So we are going to have 44. Then we are going to multiply by the mass of the carbon dioxide given in the question, which is 5.28 grams of carbon dioxide. So we are going to have 12 over 44 times 5.28 grams. So here we are going to get 1.44 grams as the mass of carbon. Then on this other side, it is the same. We are going to have the mass for hydrogen, but hydrogen is gotten from water. So how do you write water? H2O. How many atoms of hydrogen do you have in water? 2. So it will be 2 times 1 for the atomic mass of hydrogen, or for the RFM of water. That's 1 times 2 plus 16 for oxygen. So this will be 2 over 18. So here we are going to have 2 over 18 times the mass of water given in the question, 2.16 grams of water. So we are going to get 0.24 grams. So the molar mass of carbon is 12, the one for hydrogen is 1. So the moles will be mass over molar mass. We are going to get here 0.12. The other side, 0.24 divided by 1, we are going to get 0.24 moles. Okay, the mole ratio, we are going to have 0.12 in the side of carbon divided by the smallest or the smaller moles, which is 0.12. Here we are going to get 1. Here we are going to have 0.24 over 0.12, which is now the smaller moles. Here we are going to get 2. To write the empirical formula, it will be C1, we don't write that one, then H2. So that's CH2. Okay, so if you have the empirical formula, that means the molecular formula can be determined by CH2, which is the empirical formula. N will be equal to the molar mass or the molecular mass. The molecular mass of the hydrocarbon is 84. So this one will be equal to 84. So carbon, which is 12 as the RM, and 1 times 2 for hydrogen, close bracket, N will give us 84. So here we are going to get 14 times N, that's 14N, will be equal to 84. So if I want to get N divided by 14, divided by 14, N will be equal to, here we are going to get 6. So we take again the formula, the empirical formula. It will be like this. Then where we were having N, we are going to replace with 6. Then we are going to remove the bracket. Here we are going to have C6, then H12 as the molecular formula for this compound or this hydrocarbon. So if you are a Form 4, you can be told to calculate the molecular formula like that, and down they will ask you a question, name the homologous series to which the hydrocarbon belongs. So it will be an alkene series because it conforms to the general formula of CnH2n. So next they can ask you again, name the hydrocarbon. So this hydrocarbon is hexene. It is hexene. It's not hexane, it's hexene. Okay, we go to the second question. That's number 7. Question number 7. We are told a hydrocarbon containing 8% carbon by mass, given that 1 decimeter cube of the compound at STB has a mass of 1.34 grams. Calculate the molecular formula of the hydrocarbon. Molar gas volume at STB, that's the standard temperature pressure, will be 22.4 decimeter cube. Okay, Here, they are asking us the molecular formula. So for us to do molecular formula, we are supposed to have our empirical formula. So the empirical formula can be determined like this. I've already done for you. So you have to have the elements. We are dealing with hydrocarbon, and the elements in hydrocarbon are carbon and hydrogen. So the symbol for carbon and hydrogen is as that. Then the percentage composition, 80 for carbon, then that means the remaining will be hydrogen. So 100 minus 80%, we are going to get 20% for hydrogen gas. Then the molar mass for carbon is 12, the one for hydrogen is 1. Okay, the moles. Moles is given by percentage over molar mass. You see here, this percentage was by mass. So mass over molar mass. Here we are going to get 6.67. The side for hydrogen will be, we are going to get 20. So there, mole ratio, we are going to have 6.67 divided by the least moles. The least mole is in the side of carbon, that's 6.67. Here we are going to get 1. The side for hydrogen, it will be 20 for the mass of hydrogen divided by, for the moles of hydrogen divided by the least moles, that's for carbon, 6.67. We are going to get 3 here. So we are going to have CH3, because we have C1, we don't write that one, H3, that's what we are going to get CH3 as our empirical formula. So to write the molecular formula, we are supposed to have our formula, which is empirical formula, close bracket, and will give you now the molecular formula. But here we don't have the molecular formula. We have to get the molecular formula from the information given here. We are told given that 1 decimeter cube at STB has a mass of 1.34 grams, 1.34 grams. So what about 22.4 decimeter cube? That's the molar gas volume at STB. So we are going to cross multiply. Here we are going to get 22.4 times 1.34 divided by 1. Here we are going to get 30. So that is the molecular formula for this hydrocarbon. So we are having the empirical formula as CH3 close bracket, N will be equal to 30. Carbon is having an RM of 12 times 1 plus 1 times 3 for hydrogen close bracket, N will be equal to 30. So this will be 15, N will be equal to 30. If I want to get N, I divide it by 15, I divide it by 15. So that means N will be equal to 2. So there we can have again the empirical formula. The empirical formula was CH3 close bracket, and my N here I've gotten 2. So I have to write 2, then I remove the bracket, and I'm going to get the molecular formula as C2, then H6. So this will be the molecular formula for that hydrocarbon. Then there, question 8, we are told if 7.36 grams of a compound decompose to produce 6.93 grams of oxygen and the rest hydrogen. If the molecular mass of the compound is 34, determine the molecular formula of the compound. H is 1, O is equal to 16. Okay, for us to get the molecular formula, we have to get the empirical formula. We write element, hydrogen, oxygen, the symbol HO, the mass. For hydrogen, we are going to say 7.36 grams for the whole compound minus 6.93 for oxygen, so that we get 0.43 grams for the mass of hydrogen. Then oxygen is given here, 6.93 grams of oxygen. So the molar mass for hydrogen is 1, the one for oxygen is 16. So the moles will be mass over molar mass. That means 0.43 divided by 1, we are going to get 0.43. The side for oxygen, the moles will be mass of 6.93 divided by 16. Here we are going to get 0.43. Then the mole ratio, we are going to get 0.43 divided by 0.43 because the two have the same moles, so we are going to have 1. Here we are going to have 1 as the mole ratio. So the empirical formula will be H1, we don't write 1, O1, we don't write 1. So it will be HO. That will be the empirical formula. So for us to write now the molecular formula is given by HO close bracket, N will be equal to the 34 that they have given us in bracket. So H for hydrogen, we are going to have 1 plus 16 close bracket, N is equal to 34. So 1 plus 16, that's 17 times N, 17N will be equal to 34. That means to get N divided by 17 divided by 17, N here will be 2. So let's have the empirical formula. It will be HO close bracket. So we replace N with 2 because we have gotten the value of N, which was 2. So to remove to get now the molecular formula, we are going to have H2 then O2. So we are going to have H2O2, that's hydrogen peroxide. So next we are going to go to question 9, which is an extended question. So we are going to have one extended question. That's the end.